All right, so for day one, we're going to do some pre-cal review. In this lesson, we're going to mainly focus on a lot of algebra, how to simplify rationals, how to factor again, that sort of thing, and rationalize denominators. Because in calculus, we will be doing a lot of algebra in it, so I have to make sure that you're good to go for that. So this is the worksheet that's attached onto your OneNote. So you can just download the PDF version of it or the Word version of it, doesn't matter, and print it out for yourself and try these on your own. I'm going to kind of guide you through these questions by doing some examples that are just like them so that when you can do these on your own, you have an idea of how to approach them. I'll also write the answer key in here by the end of this week, just so you can try these out and then you can check the answer afterwards. Okay, so for this question, we have a bunch of fractions divided by more fractions. So I'm going to do an example on the side here, kind of like that, and I'll just create something myself. So let's just say I have something like this. So it's kind of like that first question here. What you probably want to do is try to simplify the numerator and the denominator and then try to divide them afterwards. So I'm going to just focus on the numerator. In order to add these two fractions, I have to make sure I have a common denominator. So I want to make this into a 6, and I can do that by multiplying top and bottom by 2. So we get 2 over 6 plus 1 over 6 then for my numerator. Then for my denominator, again, I want to look to see how I can change this 5 into a 10 so I can have a common denominator. That means I can multiply top and bottom by 2. This will give me 4 over 10 plus 1 over 10. And then now I'm going to add my fractions. So 2 plus 1 is 3. The 6 remain at the bottom. 4 plus 1 is 5. The 10 remain at the bottom. So I can even go a little bit further and simplify my fractions. 3 over 6 is the same thing as saying a half. And 5 over 10 is still the same thing as saying a half. So a half divided by a half, those are the same things. So that's just going to be 1 is your final answer. Okay, so I'm looking at some of these here. I'll probably do one that requires a hard one like this one. That's a rational with a negative exponent. And I'll also look at some square root ones. So looking at B, I'm going to create another one. So it says evaluate or simplify. Most likely we're going to simplify something like this. Okay, so let's say that that's what my question was. There's a couple things we can do. You can multiply these out right away. Because when you multiply, you can multiply whatever's inside the square root sign. But however, don't do that for adding. It's just for multiplying and dividing that you can do that. Or we can also just simplify this first, and then simplify this one, and then multiply them together after. I think that's the method we're going to use just because I don't really want to do 24 times 18 and then trying to simplify that is kind of a lot of work. So in order to simplify this, the root of 24, to think about, okay, what square roots can create 24? I know that 4 times 6 creates 24, and that 9 times 2 create 18. The numbers I choose here have to be perfect square numbers so I can take the square root of them. So the square root of 4 is 2. I'm going to leave it on the outside. I can't take the square root of 6, so I'm going to leave it on the inside. Then I'll move on to this one. I can take the square root of 9, which is 3, so now it's on the outside. I'm going to leave the 2 alone because I can't take the square root of that. Now we can multiply these. So 2 times 3 is 6. And then we multiply whatever's on the inside, so 6 times 2 is 12. Now we're not done here because it looks like we can simplify this a bit further. 12 can be rewritten as 4 times 3, and I can take the square root of 4. The square root of 4 is 2, so we'll leave that on the outside and leave 3 on the inside. So this will be 12 root 3. Okay, so how you should approach this is to simplify each root and then multiply them afterwards. I'm going to do a rational question, another example here. That's kind of similar to this maybe. So okay, let's say this is all to the power of -2. So you should work on the inside first before you do anything. You would focus on the numerator and then focus on the denominator and see if there's anything we could do there. But since we're dividing, we should combine our like terms. And then this -2 just means that the negative part just means we need to reciprocal it to become positive and then square all those numbers. So what we can do is, I think I would rather just focus on the inside to simplify it first. So know that 2 over 4, that's the same thing as saying 1/2. So I could just leave 2 in my denominator. This x divided by x to the -4. Because we're dividing, there's an invisible 1 there. So when we're dividing with the same base, we're going to subtract. So that's 1 minus -4. So minus is plus. We're going to be left with x to the power of 5. Then here we have y minus 4 and divided by y. So that's -4 minus 1. This is y to the -5. Or you can put it down in the new denominator, and this will be y to the 5. And then z, 2 minus 3 is -1. So if I could put up here, it's going to be z to the power of -1. If I want it to be positive, I just throw it down here. Now we can reciprocal them to get rid of this negative exponent. And then distribute this 2. So this 2 is going to go to everything inside the bracket. So 2 to the power of 2 is 4. Remember, power to a power, you multiply exponents. So y is 5 times 2 is 10. Then z squared over x to the power of 10. You can also do a different way if you wanted to. So this is one method. You could have also did the reciprocal first and then square everything inside and then subtract them. I think this is a little bit more quicker though. I was able to do it in 3 lines. So factoring is huge. It was huge in pre-calculus. It's going to be huge again in AP Calculus. So I'm not going to go over factoring because you probably have done that in grade 10, 11, and 12. So I'm assuming you know how to factor. Just remember that this requires some synthetic division because this has a power that's larger than 2. I'll just do 2 more examples and that'll be it for this video. So we have for question 4, again, some rationals and we want to simplify them. So maybe I'll do one that's like b. Actually, I'm going to change this. So let's just say we have a question just like B. Before we do this flip and change this to a multiplication, we can try to factor these out first, because they do have a number in common between these two terms and a number in common between these two terms. So I can factor out a 12 in the numerator here. And that'll give me 12 times x minus 2. I can factor 15 out. And that'll give me x minus 3. And I can see that I can simplify this 12 over 15 with 4 over 5. Okay, now I can do the multiplication and flip. So when you divide fractions, that's the rule. You change to multiplication and flip your fraction, your second fraction. And then we're going to multiply this out. So when we multiply fractions, numerator times numerator, so this is going to be 5 times x minus 3. Your denominator, we can just maybe multiply the 3 and the 4, which is 12, left with x squared times x minus 2. And really, when we look at this, the only thing we can really do is expand these last few ones. So I guess we can do that and then we'll be done. So it'll be 5x times, or 5x and then minus 15. So that's 5 times x and 5 times negative 3. Then we'll take this whole term, 12x squared times x, and then times it by negative 2. So that's 12x cubed minus 24x. This would be either of these forms are fine. This one is just your expanded form. This is just a factored form. But there was nothing else for us to really do here in order to simplify it further. So this is the simplest form.